All right, so recap from the video that is unusable. If we have rate times time equals distance, I can solve this for rate by dividing both of these sides by time, and I've got rate equals distance over time, miles per hour, kilometers per hour, feet per second, whatever you measure it in. The new concept from lesson 38.c is overall average rate. It's just a slight tweak on what you already know. You know that rate is distance over time. What we're saying, as an extension of this idea, the overall average rate is the total distance divided by the total time. And you might be thinking, what's the difference?
What is the difference?
Excellent, good question. Glad you asked. Otherwise, that would have been a really awkward pause. If we have a journey, I like to call it a journey, that has multiple segments with different distances, times, and rates, you can get the overall average of the entire journey like this. And these can be very confusing if you don't set them up well. So here's how I set them up, and I strongly suggest that you set them up the same way. Example 38.7. Frank and Judy, lovely couple that they are, drive for 100 miles at 50 miles per hour. So they're going 100 miles at 50 miles per hour. I'm just jotting this down for now. And then they drive 180 miles at 60 miles per hour. And then, okay, so what's the overall average rate for the whole trip? Okay, this one's going to be pretty simple. This one's not going to be that big a deal because they gave us all, excuse me. All right, let's call this D1 and D2. What's the total distance?
This is going to be a magic trick.
280 miles.
Okay, the total distance is going to be D1 plus D2 is going to be the total distance. Total. D1 is 100 miles, D2 is 180 miles, so our total distance is 280 miles. Now, what about total time?
2 hours.
Roughly.
No,
110.
don't sway the camera. That's just mean. Okay. For the first leg of the journey,
It wasn't for you right now. It's okay.
for the first leg of the journey has a rate and a time and a distance, right? 1, 1, 1. Our distance for the first leg was 100. The rate was 50 miles per hour. What's the time?
115 minutes.
50.
Actually, no, it's not 2. 2 hours.
2 hours.
Just kidding, it's 2.
That's right.
3. Aww.
But you got it.
I know. The second leg, of the journey has a rate times time and distance. So 2, 2, 2. The second leg distance, problems aren't going to be that complicated. The distance, the second leg of the journey, the distance is 180 miles, the rate is 60 miles an hour. What's the time?
2, 3.
2, 3.
Okay, she was the first one with the right answer. I don't know what the rest of your...
I'm
completely lost.
Okay.
Is it
In this leg of the journey, they went 180 miles at 60 miles per hour.
Okay.
So focusing in just on this leg of the journey, they have a rate, a time, and a distance. They went 180 miles at 60 miles per hour. How much time did they spend driving during this leg of the journey?
3 is already
3 hours. Well, yes, but I was hoping for a glimmer of recognition or understanding in the eyes.
Just fake it. Like
I understand how
a
you got
flash.
that, but how you think that was the problem
Fake it.
is like the hard part.
Which one was that? Oh, I gotta watch that.
I don't know.
I gotta
skip the
How
one.
you
I
step
gotta
from
watch
one
it.
of the equation, and from the equation you find the time, and from the time you know where to plug that in, and then you plug that in
Did you
here, and
just
then you
flash?
find the actual answer. And
Well, just hang.
it's like the thought process is what I can't get.
Okay, let's finish this example. Then we'll do another one that's more involved, and I'll draw it out a little bit better on the other one. Okay, so the time spent on the second leg of the journey was 3 hours. So coming back to here. So what is the total time then?
5.
The total time is the time spent on the first leg of the journey plus the time spent on the second leg of the journey, which is a total of 5 hours. So the overall average rate, Dwight, is the total distance divided by the total time. Total distance, 280 miles. Total time, 5 hours. And I'm running on a slant here, sorry. That comes out to,
Hold on.
somebody with a calculator.
280 divided by 5 is 56.
Miles per hour. Because it's a rate. Now, does that seem reasonable? If you drive for 2 hours at 50 miles per hour, and then for the next 3 hours you're driving at 60 miles per hour, your average rate for the entire 5 hours is going to be somewhere between 50 and 60.
55.
It's 56.
Close, 56.
Oh. Close enough. What's 1 mile per hour difference? I mean,
A redo?
Oh.
Yeah,
looks like a
math
6, but it is really
term.
a 5, but it also looks like a
Red.
6.
Okay.
My eyes burn.
You should have cut that one, Vito.
Alright, so this was the simpler example. Let's move on to
That was
bigger.
a simple one.
Yes, that was the simpler one.
Unless it could be like,
38.8. Frank and Judy. Going that far wasn't enough for them. Now it says that they're going to drive 100 miles at 50 miles per hour, and then they're going to drive 180 miles at
Where are they
60
going?
miles per hour. I have no idea.
This is the same
Problem?
Yeah, I'm guessing their vehicle broke down and they got a ride back home, and then they decided to do the trip again. That's just my guess. And let's see. So then it's 100. So 180. Excuse me. So then their second leg of the journey, 180 miles at 60 miles per hour. And then it says, how fast should they drive for the last 120 miles? So there's another leg of the journey of 120 miles at, we don't know how many miles per hour. So that they want an overall average rate of 60 miles per hour for the whole trip. So they want an overall average rate of 16 miles per hour for the whole trip. So what I've done here in red is I've written out all the information from the problem. Wait a minute.
What if they're traveling on not a straight path?
Orange!
Blue!
I couldn't
All
see.
of them at once.
Can we just trade them out? Trade all of them out?
No, these things are annoying to use more than just a little bit. All right, so the question is,
Do you have
in neon blue, I don't think so.
Very neon.
No, I don't have neon brown.
Like,
Do neon green too. There's no such thing as neon brown.
Okay. All right. So here's the information from the problem.
No, if you go.
We have the first leg of the journey. They gave us the distance and the rate. Second leg of the journey, they gave us distance and rate. There's a third leg of the journey. They gave us the distance. They're asking for the rate, and they want the overall rate. Or they also gave us the overall rate. Here's how I suggest you set these problems up. This will help you a lot. Let's see. We want. Okay. I need.
purple.
A volunteer. Alright, let's see here. This is going to get pretty hairy with the markers. Let's call this the first leg of the journey. First leg of the journey.
Green.
Brown.
Let's call this the second leg of the journey. And we'll go with the
To the center of the almost.
Hey, careful with that. And we'll call this the third leg of the journey. That's a 3. That's the third leg of the journey. So here's what we're going to do. Let's take,
It doesn't feel like that.
excuse me, let's set up distance. Distance. Our first distance is 100 miles. Our second distance is 180 miles. Our third distance is 120 miles. So in red, what is the total distance?
We don't know.
No, total distance.
It's
What's the total distance?
Oh, you got them all together.
100 plus 180 plus 120.
That was dumb.
total distance. Okay? Let's do time. Were we given the times? No.
Do we need that?
We know it's going to,
Two.
hold on. We know it's gonna be in hours. And
Can it be
something in
20 something?
hours, something in hours. And we are going to, if we add up the total, if we add up these hours, I'll put a blank here, these hours plus these hours plus these hours, we're going to get whatever the total number of hours is. But we don't know that yet.
Do we need them though for this?
No,
What do you think? Let's ask Euclid. Now down here we have rate.
It's like a rainbow.
What do we know about the rate? What's the rate for the first leg of the journey?
50 miles
50.
an hour.
50 miles per hour. What's the... First one in purple, okay. What is the rate for the first leg?
50.
50. 50 miles an hour for the first leg. What is the rate for the second leg?
60.
60. Sorry about my handwriting there.
Oh, that's 60. That was 80.
Better?
Yeah.
This is an at 60 miles per hour. And around third leg,
We don't know.
we don't know.
Blue question mark.
Should we use let's use a variable name.
Okay.
You wanna-
Y'all blue.
Okay?
Yeah, please do.
All right, we'll do a K.
Not that.
Test.
Okay. That's the neon orange.
Okay.
Is pretty rad. It's
All right,
like-
now, in the first leg of the journey, we know that rate times time equals distance. Can we solve for if we know the distance and we know the rate, can we find the time?
Yes.
Yes, we can.
C.
So for the first leg of the journey,
Two.
we have a rate of
Good
50.
job.
See, rate times time equals distance. So we have a rate of 50 times we don't know what T1 is, equals 100 miles. What's T1? 2. So we have 2 hours. We have 2 hours for the first leg of the journey there. In green,
This guy's pants off.
why do I feel like you're not paying attention anymore? Might be because I'm talking. Okay, the second leg of the journey,
Stole my-
we have rate times time equals distance for the second leg of the journey. What's my distance for the second leg?
180.
180. What's my rate for the second leg?
60.
60. What's time 2?
3.
3 hours. And third leg of the journey, we have rate times time equals distance for the third leg. Third leg distance,
120.
20 miles. Third leg rate,
We don't know.
we don't know. Let's call it K for right now. And do we know what the time is for the...
No.
No.
Oh, we don't. Boy, that's going to be a problem, isn't it? Can't solve this yet.
T equals 20.
Right, what else? But what else did it tell us? It gave us this piece of information and we haven't used it yet. If you remember that the overall average rate is the total distance divided by the total time, that means the overall average rate is the total distance, which is 400 miles, divided by the total time. What's the total time?
I don't know.
It's
We
no.
can figure it
Well,
out.
so
though.
far, we know it's 2 plus 3 plus
K.
we don't know. Why don't we call this time 3 for now?
Well, can't we figure out the overall time if we do our rate times time rate, whatever, that equation, and plugging in R as 160, T equals 400, and then you can find the time. Use the RT equals D, plug in 60 as R,
So
plug in
put
D as 400,
yeah,
and you can find
good
T.
name.
No, because these 2 hours were at a different speed, and these 2 hours were at a different. Well, these 3 hours were at the same speed as the 60, but these 2 hours were at a different speed.
But don't we have the overall miles per hour and the overall distance?
Yes,
So why can't we find the overall time?
that's exactly what we're gonna do.
Oh.
Well, can't we do it with the rate times time? Like we've been finding time. Can't we do it the same way we've been finding all the other time? By using the rate times time equals distance equation.
Yeah. Okay. Let's explore that. Rate times time equals distance.
So 60.
Total distance of there we need the overall average rate is 60, what do we plug in for the time?
T.
Okay? And I'll do T sub T for total, so what's the total time?
I don't know, whatever that is.
A big number.
It doesn't go any equally.
Okay?
It's not even.
What does it come out to?
20 over
6.8, I'm
20
guessing.
over 3 or 6.6?
No, I'm guessing, I'm not
20
sure,
over 3.
it's at least,
6.6 or 20 over 3.
Okay? So the total time is 20 over 3 hours. What are we gonna do with that?
Plug it in.
So then we can
By the
solve
way,
it.
that's exactly what I was gonna do here.
Oh. By a half.
Except what I was going to do was, this 20 over 3, we get is 2 plus 3 plus T3. So that's going to be 2 plus 3 is 5, plus T3. So the total time of 20 over 3 hours equals 5 hours plus T3. What's T3?
what do you do?
1 point. What that is in decimal.
What are we even looking for in this problem?
Well, we got to find T3 first.
Oh, fraction. I don't know what that is in fraction. My bad.
So now we know what T3 is. Yay, finally.
I think it's 4 over 3.
4 over 3 hours.
Wow, this is a big problem.
Did we?
Yes,
oh, we
that's why it helps to have it.
Color coded.
Chart it out.
Oh,
So now we know what T3 is.
Yay.
4/3. Now,
So then K
now we can finally solve
or backwards
for
Y.
basically R3 is what it is.
Or a backwards Y.
I'm gonna change. Let's call this what it is. We are solving for R3.
Okay, good.
R3. R3. So how do we find R3?
Multiply 120.
Plug in show.
Now we solve this for R3. If I multiply both sides by 3/4,
Then we get it.
then cancel, and R3 equals,
Bumbo?
drop marker, equals 90 miles per hour, and that answers the question that was asked.
Wow,
Now
that's
the viewers can't see the answer.